Hi, and welcome to this episode of Interesting Bits. This series, I just try and present you with tools that I have discovered for the first time. Maybe you've already been aware of them, maybe not. It's one of those things where everyone at some point in their life discovers a tool for the first time and what it can do. And so for me, maybe this is later and you guys have already seen some of these things, but it's just one of those things where I'm hoping that I can share something new and interesting with you like I discovered on my own. So this first bit is sort of pedestrian, except that it's sort of areas of extremes. So you might have seen this in the background of some of my videos. This tap is a 2 7/16 20 tap, and I bought it mostly as a curiosity because it was really inexpensive on eBay. It's brand new, and I think someone was selling it for 20 bucks. So I thought, you know, for 20 bucks, it's just fun to look at. Let's have it to talk about. So I bought it. This, for perspective, is a 1/2" 20 tap, and I mean 1/2" 13 tap. Very common size, and you can see it's just totally dwarfed. This is a 256 tap, and this is sort of the smallest common size you'll run across. I mean, there is 172 and 080, but they're even rarer. So to give you perspective, here's a 256 tap. If it would stay put. I got a bunch of taps from a friend of mine who was still running across stuff from his dad. When his dad passed away, he was the machinist. And this tap is labeled 0.9, so I'm guessing it's metric, is 0.9 millimeter. I don't know what the pitch is, but compared to the 256, look at the size of this thing. That's just ridiculous. I thought I had to point this out because I've never seen a tap that small. All right, so next in the sort of range of extremes, this is a 1/2" reamer, carbide tipped. It's actually 0.502, and I got this in a lot on eBay a while ago. I think I got like 30 of them for 50 bucks, and then I sold a bunch of them because they're all brand new. They're coolant through, pretty fantastic. It's a little bit unusual size. Normally over under is 0.499 and 0.501. But this is 0.502, which gives a little more clearance. It's still a pretty tight fit on a 1/2" shaft. So pretty handy to have around. So I kept a couple of them and sold the rest. But I bought a lot just very recently of small reamers, and while it's really great to get them inexpensively, problem is trying to figure out what the sizes are. So some of them I figured out the sizes. I was able to read on the side and I put them away. But other ones I can't tell, like this one, there's no writing at all. And then for the really small one here, there's writing on it, but I can't make it out because they actually printed all the way around the whole diameter or the whole circumference of this thing. Such a small diameter, even with a magnifying glass, I can't figure out what it says. So I was thinking, how do you figure out what size this is? Do you drill a hole and then try and ream it and then try and find a pin gauge? But I don't think I have pin gauges that go, you know, incrementally that small. Anyways, if you're wondering how big it is, there you go. It's just crazy. I just thought that was kind of unusual and interesting. Again, buying lots on eBay is a cheap way to get tools, but sometimes you can't identify them. Next, we have a tool that's sort of ubiquitous, meaning it's in everyone's shop, pretty much. And it's sort of the standard blowgun. So this is one I bought many years ago. Maybe Harbor Freight, maybe Home Depot, maybe Lowe's. Don't really remember. It always sort of worked, but never great. The needle blows off on the thing, and I've had to glue it back into place a couple of times. The valve is sort of uncomfortable feeling. It's too high a pressure, and there's no positive stop on the end. It sort of just gets mushy towards the end, so not very nice. It works okay. It's loud. And the design of the tip makes it so the air comes out at high pressure, then rapidly expands into a cone that increases. So it's going like this, it's going out on both sides, getting wider and wider. And it sort of blows things. It's very turbulent, and it works okay. Like I said, it's worked for years and I haven't really noticed anything. Well, a while ago, I was watching John Saunders' channel, and he had a new blowgun he bought that he had a problem with, and the manufacturer immediately took care of the problem and actually called him and said, you know, we'd really like you to send us the gun back. We want to analyze it. We've never had a failure of the type that you've described before, so we want to make sure that doesn't happen to anybody else, so please send it back and we'll send you a new gun. So this is similar to one of the ones John Saunders got. It's by a company called Sylvant out of Sweden. And it has a bunch of advantages to it. One, It has a safety tip on it. So this one's not a safety tip. So if you were to put your hand flush on this, you can get air injection and it'll blow air and bacteria and water underneath your skin, and it can cause huge problems. This one is a safety tip. As you can see, it's got lots of holes, but those holes do more than just provide safety. They also create a laminar flow that they have patented. And a laminar flow, the air all stays in a column, so it stays in a column at higher pressure farther away. So if you're blowing chips out of a tube, this one is not going to work as well as this one if it's a large tube. If it's a small tube, then the side walls of the tube will force the air to follow the path. But this one does better for large objects and just general blowing. Plus, a huge plus, listen to how quiet it is. And what you're hearing, besides my compressor, is papers blowing all the way across the shop because the column stays together better. In addition, you see this plug up here. It's also designed so that if your air hoses hang from the ceiling, you can take the plug out, put it in the bottom, put the fitting in the top, and hang this guy from the ceiling, which is kind of a neat feature for no extra cost. Now they're more expensive than these, $20, $30 cheapo ones. I think this was $80, but I think it's worth it. Also, they have a catalog, which let me bring up and show you. So after I purchased this gun online, I placed an order, and I immediately got a call back from the salesman. The salesman said, hey, I see you purchased this blowgun from us. I want to make sure you got the right one because we make a ton of different style blowguns, and I just want to know what your criteria are to make sure you got the right one. Otherwise, we'll correct it and get you the right one. So, and he also said, I'll send you a catalog just so you can see what we've got. And I told him, I'm a small home hobbyist, and I'm not going to be buying, like 50, 100 guns like a big industrial setting. He said, that doesn't matter. All our customers are important. And that's sort of the experience John Saunders had too, which is why I pursued this to begin with. So the catalog's interesting. In the very beginning, they talk about their patented laminar flow technology that makes it quieter, makes the airflow a lot quieter. Let's see if I can find it. Here we are. That makes the airflow quieter and also stays in a column much better than a regular blowgun. There's a regular blowgun air where it's constantly creating eddies and turbulent flow in the air. And I noticed myself that immediately that it's far superior to this gun. They make a bunch of industrial ends on them. So depending on what you're doing, they've got a huge bunch of different products to cover that. They're for assembly lines and things like that. They're air knives and things like that. You might have seen air knives. If you're not familiar with an air knife, creates a sort of a laminar sheet of air that sort of divides things or blows things out of the way. You might have seen one in restaurants. They have that blower at the door, creates a laminar flow that keeps the cool air or hot air, depending on what season it is, inside the restaurant and whatever air outside out. And it's kind of an efficient design. So they got a huge variety of nozzles and air knife designs and blowers for industrial settings. Then the whole back of the catalog is like, I don't know, maybe 40 or 50 different air gun designs, which is why he asked me if I got the right one. So the way I picked the one I got was based on the amount of airflow out of my compressor and quieter. So they tell you how many decibels the air gun is. And that's what I was looking for because I really wanted quiet. This air gun, that harsh high frequency really hurts my ears. This one, far more pleasant, and it's like 15, 20 dB quieter. So I recommend checking out Sylvant. Again, they're a Swedish company. They've got tons of designs. If you want all metal designs, they have those as well. These are aluminum, and I think they even have some stainless steel ones. They've got a bunch of special purpose ones that may solve some problem you're having, so check it out. Check out their website. Next, we have Deburring Tools. Now, almost everyone's seen countersinks and the really common sort of Noga or Shaviv style deburring tool. They have a bunch of different pieces that go on the end. This is a lightweight one for light materials. They also have different shapes for plastics and different purposes, and they often come in sets. A little less common one, this is a design of a deburring tool that lets you reach on behind and deburr. It's a little awkward to use, but it works reasonably well. This is a ceramic scraper style deburr, and it works on plastics and even soft metals like aluminum. And this tip fits inside this one here. So if you pull this guy out, fits in there. And this style also lets you reach into a hole and deburr even harder metals. These are all sort of common. This one a little bit less so. I ran across these others in a video a while ago, and these are from Noga, and they're a set of 3 different deburring tools, and they're designed to do front and back of a range of holes. So they come in 3 sizes. And the interesting thing is they'll deburr any style hole. So if you want to deburr the top of a hole, like here's my bench block, and I don't want to deburr this, but if you want to do the bench block, and this needs the spring set on it, but you just push down and I can deburr the edge of this hole here. I don't know if you can see that. There, it'll deburr the hole. But if I want to deburr the inside from the back, I push this down and I can have it flip the deburring tool around and deburr the part from the back, which is pretty handy. So depending on which way you set it before you go in determines how it comes out. So they have 2 different sizes. So you can see this is, if I want it to end up deburring the front, that works. And if I flip it the other way and I push it through, it'll come back to deburring the back. And they all go all the way down to this little tiny one. So those are tools that I'd never seen before, so I thought I wanted to share them. They're pretty handy deburring tools. So if you want to check them out, I got these on Amazon. Again, they're by Noga. And there's some part numbers for the 3 different sizes. Next up is a tool that's really common in the machine shop, and it's parting tools, or cutoff blades as this one's calling itself. And this is a standard high-speed steel one that's on ground, just like this is a larger version of that. This is the insert version that fits inside a tool that holds those kind of blades. And with these, you can replace the inserts. Besides parting, you can also do grooving with these. Finally, there's the style parting tool that I like a lot. They're limited as to how deep they can go. So like this could only part maybe 2-inch stock, maybe not even that much, maybe 1.5-inch diameter stock max, or a wall of a larger tube like this. It would be able to make it to the inside, but obviously couldn't part the main stock. This kind of thing seems like it's sort of limited to parting and grooving with this width, but there are some other features you can get by buying different inserts. So for one, this doesn't fit in that specific tool, but here is a rounded end, radiused end for a parting tool. So if you're doing large O-rings, or you want a groove that doesn't have failure points, you know, when you create a very sharp edge in a piece of metal, that sharp corner is a failure point. So a lot of times the radius is required. They sell inserts that have radiuses in a variety. But also, these are kind of interesting. They come in a variety of sizes. And these guys, I don't know if you can see it, but they're biased to one side, so they have left and right bias. This is, I believe, let me see if it says on here, this is the right bias. I didn't know which hand, you know, which way they're looking at things. So this is a right bias, and what it means is it's cutting first on this right side, and the thicker material will be on the left side, which means, unlike this one, which is symmetrical, when you part, the nub that always gets left as the part breaks off before you finish cutting all the way through will be left on the main piece of stock. With this one, on this one, it almost always ends up on the part. And so this will save you an extra step, because then you can go and face the material and go again. If you'll look also, this is a positive rake insert. They've ground it back so that it takes a lot less force to cut. So pretty handy. All right, so here is a regular parting tool. This is 12L14. There's lead in it, which makes it very easily machining. Okay, so we pop the part off. Now, can we find it in the chip tray? There it is. Okay, so there's the part, ouch, and the very common little bung sticking out. That's kind of hot. Here's the other one. Well, so that was an interesting experiment. It didn't solve the problem all the way. You can see how thick the center section is on this one, and you can see how thin it is on this one. Plus it's conically shaped, so it's thinner by the top. So what it will do is make this much easier to break off, but it didn't solve the problem completely. I'm a little disappointed by that. Let's just give it one more try. You can see the angle that it's cutting, so a lot less material is going to be left on the part side than the main stock side. Maybe with lube you get better results. So it did leave a tiny bit again on the inside, but it's much smaller diameter, so it will be easier to clean up. So on that note, it's better. It is not a perfect solution, so that's good to know. Next up is the threaded knob. So we use lots of these. We make some, we buy some. The one problem with a threaded knob is you've got to buy it with a specific screw length, so I typically buy them with a longer screw length and then cut it down and grind it so that it works if I need something shorter. But there's another solution, these guys, and they come in a variety of sizes, a huge variety of sizes and shapes. And what they are is thumb screws and knobs that fit on top of cap screws. So this one is designed for 1/4-inch cap screws, and all you do is just press fit this on, whatever screw size you need, and you've got an instant knob. And I don't want to push this on because once it's on, it deforms. It's an interference fit, and so it is really on there. So once you put it on, you've got a knob. Now obviously not as sturdy and as strong as this style knob, but still adequate nonetheless. That's interesting. I wonder, this was supposed to be a number 10 size. Yeah, maybe this is an odd size number 10 socket screw. Let me go grab another one. I had the wrong size. I actually bought some number 8. This is a number 8. So this round knob fits on a number 8. They've got a bunch of different styles too. So I bought a variety of sizes. That's for 1/4. This is for number 10. This is for number 8, and that's the knob I've got right here. And this one is number 6. So I got a bunch of different sizes. Basically, whatever screw, whatever cap screw, socket head screw you've got, you just press this on, and it becomes a nearly permanent thumb screw, which is really handy because you can find just the right screw length and then put a knob on it. And it's a heck of a lot cheaper than these. These are not very expensive. I got all these at McMaster Cars, so if that's what you're looking for, here's the name of the company and the part. Next, we have some pretty common abrasive stones. These are for mold making, and they're fairly soft material. They break down quickly, but they take off material very nicely, and they come in a bunch of different grits, and they let you get in, and you can wear them into a shape so that they will conform a bit. But when you have round surfaces, it's kind of pain to use these, and that's where this guy comes into play. This is a Kratex, and it's a very hard rubber that has grit embedded in it. And they come in a bunch of different grit diameters so that you can have coarse, medium, fine. This is an extra fine. And if you want to sand something that's fairly round, this is a great way to do it. A bunch of other YouTubers have been using these, and so I discovered these recently and I picked one up. I got mine on Amazon if you're interested. Continuing along the sanding vein is this idea from Tom Lipton and Robin Renzetti. And this is some adhesive-backed sandpaper. This particular stuff is 3M, and you can tell that I did not clean it perfectly before I put the paper down because there's a couple of bumps here. But the beauty of having a very flat surface and sanding stone is you can take something you're just working on and give it a quick polish on here. And I keep some lubricant over by it, so it's pretty handy to have. Continuing along this idea is this. I found this on eBay. This is a 15 micron, and this is a diamond bonded to metal. Lapping stone, and pretty handy. It's designed to work on a magnetic wheel, but I can use it lying flat on a surface just as easily, and use this to grind down carbide or anything else that needs a flat surface so that you don't end up with out of round or out of square shapes. So this is an electroplated diamond 15 micron. These are somewhat pricey though. So the Robin Renzetti's version of this used a cast iron lap plate, because then you could come up to the edge. He'd cut it perfectly trim at the edge, and since they had square edges, you could take a part along the edge as well. Some granite blocks work that way, some don't. This was from a really inexpensive stand someone was getting rid of on eBay, and so that worked for me. I also have a little Starrett 8x12 surface plate that I have a different grit sandpaper on. It works very well. Next up is something I didn't know existed, but I guess on the internet everything exists. This is from a company called Art Primo, and you can look at artprimo.com. So you know when you're using like 3M spray adhesive, the nozzles get fouled, and Robin uses some pretty toxic solvent to clean the edges of it. It has toluene in it, and that stuff's pretty nasty. You probably don't want that on your skin. But you can buy for almost nothing replacement spray caps. And Art Primo sells them that have different spray patterns, but they also work on different style cans. So instead of having to deal with cleaning it, I know I'm not a big fan of throwaway, but this is a decent solution, and this is available. Next, we have a tool that was given to me by a friend at work. It cost him almost nothing. I think the concept is better than the execution. This thing is just a piece of junk. It's chrome plated, but it feels like it's pot metal or something. I don't know. Maybe they did use hardened steel on it, but it's a deburring tool for round, or a chamfering tool for round bar stock. So here's my first use of it. I'm going to go to slow speed. You just basically stick it on, and yeah, it does a pretty decent job. It turns up kind of a burr on the end, but it does work. It looks like they're using the chrome as the wear material, because the chrome is very hard. It doesn't cut very quickly. You have to push pretty hard, and it's not sharp at all. Again, I think the execution, the design of the tool is pretty poor, but the concept's good, and it did do a decent job deburring, except you're still gonna have to take a file to it, because it rolled up an edge on this side and the bottom, which is kind of surprising. This is just mild steel, so there's really no excuse for any difficulty there. But interesting concept. I think he said he paid $2 or $3 for it. Maybe someone makes a higher quality version. Next, we have a set of tools that I'm not quite sure what they do. They're pretty odd. They have 4 little metal pieces that extend out. This one's labeled 1/2 inch or 12 millimeter. I'm not quite sure what they do. They're supposed to grab the inside of something, perhaps. Maybe something threaded. It looks like some thread cut marks in there. So maybe it grabs the inside of a threaded hole and lets you try and pull something out with reverse threads. There's a variety of sizes here. Never seen anything quite like these before, and don't exactly know how they use. Another item I picked up, which is an adjunct to Stanzikowski Barzy Industrial's Hotshot 360 ovens, which are pretty fantastic. The one regret I've always had is that you can't see inside, so I've been looking into solutions to that, and I may have come across one. So what I have here are some laser windows that are made out of quartz glass, and these were the largest ones I could find. They're 60 millimeters. They're fairly thick, and I got 2 of them because I wanted to do a double pane situation so that you'd have better insulation, so that the heat wouldn't just escape through the glass. But they are reflective coated, anti-reflective coated, which I don't know is a good thing or a bad thing. Maybe the coating will melt in the oven. Quartz glass will melt at a higher temperature than Stan's oven goes, so I thought, hey, this might be a perfect solution. I'm not sure. I was going to ask Stan his thoughts on this topic, but got these from over in China. They took about 3.5 months to get here during the COVID crisis. Anyways, just a thought. Anyone who wants to give me some feedback on that idea, let me know. Lastly, so if you're over on the mill and you're trying to find the center of a hole, say in a part like this one here, and you're trying to get your mill centered over the part, you can use a tool that's pretty old, like this, the Wiggler here. And this ball fits in here, and you put this in your quill, and it spins around, and when it stops being eccentric, you know you're on center. Another solution to that, possibly more accurate, is the Blake coaxial indicator. This is a Char's copy, Chinese copy. For small holes, you have this little guy here that can go in the center, and you can line up your part pretty accurately. This is the 1/2 thousandths version, and that's one way to do it. I ran across another version. Let's say you just have a center punch mark and you want to center on it. These can work, but not necessarily great. So I found this on eBay, and this is a centering microscope. So this guy goes in the quill, you look through here with magnification and center it up, and it's got calibration so you can pre-calibrate it so it's right on, and then you can center on something that's just a visible center point. Maybe it's not even indentation in the metal, maybe it's just a mark on the metal that you want to center on, or some odd shape, and this should help you out. I haven't played a lot with it yet. I look forward to doing that. So another tool in my arsenal. Anyways, this has been a bunch of really weird items, and I hope you found something in there that was interesting for you. Thanks for watching. Hope you find it useful. Hope to see you next time.